we've looked at exponential functions in Algebra 2. We actually got more in depth in them in Algebra 2 than we will in here. Just going to kind of hit some highlights and remind you about them in here. Exponential function means something gets either real big, real fast, or real small, real fast. Okay, we had things that were exponential growths, that the graphs of them looked similar to that. They were going along pretty level, and then all of a sudden they just shot up out of the roof. Things that are common in your word problems for exponential growth, or when you look at like stuff like bacteria underneath the microscope and it's reproducing real fast, that's a common problem that we had. And also populations growing. Like people moving out of a big city into a suburb, you see populations grow exponentially. We talk about exponential decays. They go down real fast and then kind of level out. Most common exponential decay problem is the value of a car. It loses its value real fast as soon as you drive it off the car lots. You can't ever get all your money back out of it. So we're not going to get into the word problem scenario of it today. We're just going to look at some graphs and then how to solve some exponentials. And then where that leads up to is tomorrow we'll start looking at some log functions, logarithmic functions, some fun stuff. All right, so this first one that we're going to graph here, it says f of x is equal to 10 to the x. Now, some things I know about this already. I know that's going to be an exponential growth function, so I can write that down. Why do I know it's going to be a growth function?
Because the number is bigger than 1.
At a kid, Grace, it's the exponent's on 10, and 10 is bigger than 1, which means it's a growth. It's going to go up. Okay, so my options here for graphing this, I could make my good old input-output table, and you're going to see how fast these numbers grow. Let's say I plug a 0 in for the x. So what's 10 to the 0 power?
1.
1, very good. First period didn't remember that. Anything to the 0 power is 1. If I plug a 1 in, 10 to the first. Now what happens on your next step when I plug a 2 in? 10 squared? 100. Those numbers starting to get pretty big pretty fast. What if I go the other way? Am I ever going to get to nothing? What if I plug a negative 1 in? What's 10 to the negative 1? Say that again? No, not negative 10. Good. It's 1/10. It's 0.1. So remember, when you have a negative power, it flips it and makes it positive. So it took the 10 and it flipped it. It took the reciprocal 1/10. So if I did 10 to the negative 2, it would be 1/100th. So look, those are going to keep, I know you can't see that 1/100th down there. Those are going to keep getting smaller and smaller and smaller, but they're never going to reach 0. Okay? The next one will be 1/1000th, and then 1/10,000th, and then 1/100,000th. Keep getting smaller, 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 but never hit 0. That's called an asymptote, when you approach something but never touch it. You get closer and closer to it, but don't touch it. All right, so I know if I looked at these on my graph here, if I go over 0 up 1, be somewhere in that area. If I go over 1 up 10, I'm going to be way up there underneath the T. If I go over 2 up 100, I'm off of my graph already. I didn't make it big enough to count to 100. If I go negative 1 and 1/10, that's left 1 and 1/10, as far as I'm concerned, is as close as I can get to the x-axis without touching it. And then negative 2 would be even lower, so that graph will look like that. Now what you need to do is, however you're going to graph this on an assignment or a test. If it's going to be on your calculator, that's great. Practice it right now. Make sure you can graph that in your calculator, and then you can go to your table and get some points. Everybody good? Nobody needs to practice on that? Alright, so next one I got here says, back up what we need. G of x is 1/4 to the x power. Alright, what type of graph should I be expecting? I know it's going to be an exponential because I've got a variable in the exponent spot. Should it be an exponential growth or an exponential decay? Decay. Grace has got it again. Why? Tell them, Grace, is it a decay?
Because it's less than 1.
Very good. 1/4 is smaller than 1. So my exponent's on a number smaller than 1, so it's going to be a decay. So it means it's going to be going downhill from left to right. So if I go here with my good old input-output again, I like that 0. 1/4 to the 0 is 1. 1/4 to the first is 1/4. 1/4 to the second is 1/16. So those keep getting smaller and smaller. Let's go the other way. What's 1/4 to the -1? What we just say a negative exponent does?
It flips it.
Very good, Grace. It flips it, makes it positive. So if I do 1/4 to the -1, that would flip the 1/4 and it'd be a +4. So then if I did 1/4 to the -2, that'd flip it and square it, it'd be 16. So I'll go left 2 up 16, left 1 up 4, over 0 up 1, 1 1/4, and then they keep getting smaller and smaller and smaller. So I'll get something, hey, I did that one pretty good. Something looking similar to that. Okay? It doesn't, if you want to do it on a calculator, that's fine. Make sure you can do it though. Don't be asking me on test day because I'm not going to be very nice. Alright, both of those two that we've done so far were right there in the y-axis on our graph. They weren't scooted any. They didn't move anywhere. So we've got to look at one that moves a little bit, and then we'll get on to solving some equations, which is the funner, more fun, funner, whatever stuff. Y'all we need that? Alright, this one says f of x is equal to 2 and then 4x minus 3 is all in the power. That's a 4 that looks like chicken scratch. 4x minus 3. Okay, what I'm going to need from you is 4 points. So figure them out. Either do it by hand the way I did, or type it in your calculator and go look at the table. But I'm fixing to pick on you and ask you for some points. So either by hand or on the calculator, does not matter. Caleb, you got me a point, Mr. Plunkett?
I think so.
Tell me one.
1, 2.
1, 2. Everybody got agreed with 1, 2? Get a couple nodded of the heads there. That's all right. Kaylee, you got me one?
232.
232. What do you think about that? Boy, that went way up high. Grace, I think that must be a growth, huh? Yep, Grace concurs. I like it. All right, give me another one, Captain Crane.
3 and 5 12.
Ooh, I sure don't want to count that one. 3 and 5 12. That'd be fun. 1, 2, skip a few, 5 12. Anybody got me a negative?
They're not nice.
Uh-oh.
They're not nice.
You don't have a whole number one?
It's like
Me?
-1 and like
Woo,
1.0078. It'd be
those-
1.
Yeah.
For me, I got -1.
Yeah.
1/138.
I'll take the 0 on that, but Rachel, I like the way Rachel said it. They're not nice, and I agree.
You should
When I-
see the -2.
Now I did have, and while we're talking about this on these not nice ones, some people in first period didn't know what that E meant. You know, scroll down through there and see you got an E. They thought it was some kind of error. If it's ever an error, it will spell it out. It will say ERROR. That E is how your calculator writes scientific notation. When we write something scientific notation, we do times 10. Those calculators put that capital E in there. So that's what that's talking about. And they do get very, very, very small and they go to scientific notation. All right, so I can, and you've got one on your calculator, some of y'all, I can get a good idea of this graph real quick. It goes right 1 and up 2. Then it goes right 3 and up 32, and then up 5 12. So it's going to keep exploding up there. And at 0, it is almost at 0. 0.125 is pretty stinking close to 0, isn't it? So it's going to bottom out quicker than the other ones did. The other ones crossed, I'm getting better at that. The other ones crossed the y-axis before they bottomed out. This one would bottom out pretty much at the y-axis. I bet on your calculator it almost looks like it hits it, doesn't it? Yeah, maybe. Probably because, these are archaic calculators. Oh, thank you for interpreting. Caitlin, Agnes, Crane. Agnes, terminal name. Caitlin, Agnes, Ann, Crane. Ah! No, I'll find you one in a minute. It'll be better than Agnes, Ann. I'm thinking Eunice, Keston Eunice for this.
What?
I want to give everyone old lady names.
I got one.
You already got one?
Patricia.
Grace Ann, that's not old lady.
Patricia.
Oh, Patricia. Could be Patty or Patsy or.
Patrick.
Patty.
Patricia.
Are you gonna go by like Patty one
No.
day when you get old? No.
She's going to go out GT. That's her name.
Yep.
Alright, let's solve some exponential equations now. This is the fun stuff. Y'all are good at graphing. I got 25 to the x is equal to 125. We got to figure out what x is. Now, here's what I need you to use some common sense on. You should know this isn't going to be a whole number answer. Because if I look at 25 to the first power, that gets me 25, right? If I then squared it, 25 squared, 25 times 25 is big, it's 625. So I jump from 25 to 625. I'm looking for where it's 125, so it's somewhere in between there. So that means it's got to be between 1 and 2. So it's going to be a fraction, or a decimal, 1 something, right? Okay, we're going to review, we learned it in Algebra 2, we're going to review how to solve that using a logarithm starting tomorrow and into next week. But for today, our plan of attack is going to be to rewrite that using the same base. So I want you to look at those numbers, 25 and 125, and try to use some common sense and guess what you think a good base number would be that's friendly with 25 and 125. And Keston Eunice is right, it's 5. Okay, I just rolled right out there, Keston. So 25 is the same as 5 squared, right? And then there was an x up there. So you bring that x down with it. I got to figure out 125 is the same as 5 to the what power? Ask me, GT. I said 25
Okay,
is...
so it's because it's 5 squared.
Yes.
25.
Uh-huh. Now we're trying to figure out 125 is 5 to the what power? Come on, pick up the calculator if you don't know.
0.
5 to the 0 is not 125, but thanks for trying. That's more than a lot of people did. Very good, sir. Rutledge. 5 to the third is 125. Now it's easy schmeezy, because if our bases are the same, 5 and 5, those are equal. That means the exponents have to be equal. So you say 2x equals 3. Solve that for x. What would you do to solve that for x?
Divide.
Divide by 2. And you get 3 halves or 1 1/2. Now look at what we said common sense wise. We said it had to be somewhere between 1 and 2. Is 3 halves between 1 and 2?
Yes.
Yes, it's exactly halfway between 1 and 2. Wasn't that a coincidence? Alright, I'm going to stick with those same base numbers before we move on to make sure we'll do one more with those base numbers and then we'll throw some new ones. Got fraction issues here. I got, well, not yet. I got 25 to the x minus 2 is equal to 125 to the x. Now, like I just said, we stuck with the 25 and the 125 because when we're adding something new on here, I don't want to confuse you about base numbers. So since we just did a 25 and 125 and we used the base of 5, guess what? You're going to do that again. So nothing new there. So 25 is the same as 5 squared. But this time, look what was already up there that you got to bring down. An x minus 2. Notice how I wrote that? That's important. Because we're going to have to distribute, aren't we?
Yes.
Okay, 125 is the same as 5 cubed. We already figured that out. But there was an x up there. So bring down that x. Easy stuff now. 5 is equal to 5. Yep. So here we go. Keston's already distributed. 2x minus 4 is equal to 3x.
So we don't do anything with the days?
Once you get them the same, they're out the door. Okay, what do we got there?
Cindy Donaldson, please come back for others.
That's a one step to solve that. What we got there?
Subtract.
Good. Subtract 2x, and what you got?
Negative 4.
Negative 4 equals. Yep, it's 3 minus 2. 1x is the same as x. Good job. That's it. Got a couple more. Gonna switch bases on you now, though. Makes that to learn some new ones. Oh my goodness.
Those do not.
Got what we need on that one? All right. 4 to the x is equal to 1 over 32. All right, so 5s are out. Obviously, I can't rewrite 4 with a base of 5. So 5s are out. So looking at a 4 and a 32. Let's not worry about the fraction yet. We'll have to worry about that in a minute. Looking at the 4 and the 32. What be a gut feeling for a base you want to try with the 4 and a 32? 4. Okay, 4 is a common one. Let's look at 4 and see if it would work or not. We know 4 to the first is 4, so that would work on the first one. 4 squared is 16. 4 cubed is 64. I didn't get a 32 in there. Okay, so good idea. I like it. But we got to try something else.
2. Higher than 4?
It could be, but let's look at what Aaron suggested. He said 2. So 2 to the first is 2. 2 squared is 4. We need that, so that's good. 2 cubed, 2 times 2 times 2 is 8. 2 to the fourth is 16. 2 to the fifth is 32. So that one got both of the ones we need. Okay, so we just guessed kind of on the 5 a minute ago, but now you know how and why, what we were looking for there. So 4, I'm going to rewrite that as 2 squared. And then there was an x up there, so I put the x with it. All right, now we know 32 is 2/5, but I got 1 over 32. So what kind of power would I use to, very good, Zane, to flip that? I'm going to make it a negative 5. So I'm going to say 2 to the negative 5th. Okay, now 2 and 2 is the same, so like Keston said, we don't got to worry about that anymore. Exponents, 2x is equal to negative 5. Divide by 2, and x would be negative 5 halves.
So you wouldn't have to rewrite it because you learned that.
Mm-hmm. I like those kinds of problems. Cool stuff. I got one more. Can you handle it? Yep, you can. You don't got a choice. You're smirking at me, Claire? Yeah, because I will kick you in the teeth. I know.
You still got a Bible too.
Yeah.
Huh? When will start school?
I don't know. All right, here we got 3/4 to the x. Got double fraction action. That rhyme is equal to 16 over 9. All right, we gotta figure something out on this one. Something's got to dawn on us. Kind of gotta have a light bulb moment here. Anybody's light bulb flickering yet?
4 goes into 16, 3 goes into 9.
Ooh, whoa! Grace is on full LED high wattage. I don't know if any of that makes sense. So she's relating these diagonally. 3 and the 9, and the 16 and the 4. Which means we're going to have to, go ahead, Aaron. So which means we're going to have a negative to flip one of them. Very good. Good job, Aaron and Grace, on that. So, let's keep 3/4. What would we need to do? We keep 3/4 to the x the same. Would that be all right?
Yeah.
And now if I got to make this one a 3/4, I had to take the reciprocal like Aaron said, so I'm going to have a negative. And negative what would make that be a 9 and a 16?
-2.
Squared. Very good. So to the -2 power. Very good. And now check that out because that's already solved for you.
Is that a 2?
No, it's something. Yeah, it's supposed to be. If 3/4, and that's hard to tell, is equal to 3/4, it's already solved. You don't have any work to do. X is equal to -2. Easy schmeezy. Okay. All right. We'll also, like I was telling you a little while ago, get refreshed on how to solve those logarithmically, doing log equations. I'm going to use base, exponent, and number. When we did that in Algebra 2, that was BEN, B-E-N. So we'll use those in acronyms to help us get through logarithmic stuff. We'll start on that tomorrow. Friday, you're going to have an assignment. And then towards the end of next week, we'll have a test. We still got it's still early in this one. We got about a week's worth of log stuff to do.
Wait, when?
Huh?
When did you say the test?
Probably the end of next week.
Oh.
Okay?
That's
Mhm. This will be part of it. All right. Everybody good?
And yesterday's stuff's the hardest part.
What was yesterday's stuff? I've already forgot.
Inverse functions.
Oh, no. Inverse. I don't think so. Inverse isn't hard. You switch the letters and solve for the new one.
You said, I don't know.
It might have been harder than today's stuff. Today's was easy, I thought.
Right.
Maybe that's what I said.
Okay.
We'll go with that. All right, I did not do exit question first period, so I won't do y'all one, so y'all can hook on that. Sorry to disappoint you.